Today we're going to solve HackerRank question, tree height of a binary tree. So the question is, the height of a binary tree is the number of edges between the tree's root and its furthest leaf. For example, the following binary tree is of height 2. So for example, the longest height here could be 421, 467, etc. But we'll just look at 421 for now. So we see there are 3 nodes in this longest height and only 2 edges. So the answer is 2 because we are looking at the number of edges between the root and the furthest leaf. And similarly for this input, we see the longest number of edges is 3. The longest path is 3, 5, 6, 7, so that's 4 nodes and 3 edges, so return the value 3. And yeah, this just confirms what I said. So this problem can be done easily using recursion, where we explore all the left subtrees for each node, the right subtrees for each node, and get the longest paths. Okay, to code it up, I'll just define my recursive helper function up here. And I'll need a base case here. So my base case would be if root is equal to none, then return -1. So I want to return -1. I'll tell you why in a minute. So then what I want to do is for each node defined as root here, I'm going to explore equals, I want to explore the left subtrees. That left +1 because we're counting this node here. We're counting the root here, so we're counting that as the +1, and then we're recursively exploring the left subtree. And similarly, I want to do that for the right subtree. Equals, let's copy paste this. So again, we're at the current node here, we're counting that as +1, and we're recursively exploring the right subtree. And then finally, we want to return the maximum heights of left height and right height. Okay. And the reason we do -1 here is effectively what we're doing here is counting actually the number of nodes in the longest path. And we want the number of edges actually, and you might remember in the definition of one of the properties of the trees is the number of edges equals the number of nodes -1. So like here we have 3 nodes, the number of edges is 3 - 1, 2. And this -1 effectively does that -1 operation for us. So here we're counting the number of nodes, and -1, we're subtracting 1 from them to get the number of edges. Okay, and then over here I'll call this function return and there we go. Let's see if this compiles first. Okay, and we'll submit it. Okay, great. And the runtime of this is linear O of n time because we are visiting each node once. And in the case where we only have one node, the problem is set up here the height of a binary where a single node is taken as 0. So if we have only one node, we'll do these recursive calls and end up with a height of 1, but then we wind up with root being none, so 1 minus 1 is 0, and we'll get return 0. Okay, thank you. Bye.